Good afternoon. Sorry for delay. So this is day 2. In the last class we were taught classification using deep learning, and today we are going to see object detection using again the same deep learning. Specifically, we are going to use TensorFlow 2.3 version for doing this. And before in all the applications using deep learning, we should understand how to maintain the data or how to provide the data to the model. So data, we have to process it. We have to make it ready for the model to accept it. So in case of object detection, image is not only the data that is going inside the model. Along with the image, we are going to provide annotations which are going to be used for the detection. Now, image classification and image object detection is slightly different. In case of image classification, the whole image is to be classified. The whole image, whatever we are providing, so that will be having one label to it, attached to it. In case of object detection, the image consists of many different objects. One single image consists of different objects, and for each object there will be a class, and where is that object in the image, so that we have to mention. So that is where the object detection comes into place. So we're going to identify where that particular object is present inside the image, and we're going to define a class for it. So this for doing this detection, we need to have the location of the object inside the image. That location information we have to provide by drawing a rectangle. So that rectangle information is going to be saved in general as an XML file if we are using a specific tool called as label image. Right? So there are many tools available to do the annotations for object detection applications. So I'm going to select which is going to be very easy tool, label image. So the first link what we have provided, you can download it from there, and you can open, extract it, and then you'll be seeing so after you're going to download that, you're going to see going to download it. So you have all the list. Windows and Linux both support. This software supports in both the operating systems. So download this Windows Suite 1.8 version, latest version. Today is a completely hands-on experience. So you are going to apply using our flow. You are going to do the object detection task. So it will take some time. So once it is downloaded, of course, those who are having this PDF file, all the download links, you might already done it. I'm just opening that, extract it to the same location, and then open that. You'll see the file label image application. You double click that. Once you have this is going to be your screen. So this is the label image. So in which you can use open an image file or open directory. Generally, your data sets, whatever images are there, those all images will be kept in the directory. So you're going to select a directory for it. So for the time being, I'm just randomly picking one directory in which images are available. For the timing, I'm just selecting some images, right? So I'm going to, this is a face image directory. On this, I'm going to draw rectangles, right? So here, create rectangle box is there. So here I'm going to select, and I can draw whatever object that I'm going to detect, and define that. What is that object? Keep it okay. So this object is ready. So it is saved. Now again, I'm going to draw again another rectangle box for which you can use W. So this is the shortcuts are there so that you can do this annotation process very quickly. W, you will have another rectangular box. You can draw an eye. It is an eye. So eye object, another W. Again draw. I automatically, previous label will be automatically taken in part. Okay. Now everything is done. So control save. And where you are going to save that, it will be saved as XML file in the same directory where you taken the image from. So you can save it. Right. That is how one image you did the annotation. So the same thing you are going to repeat. Now the next image you can press the shortcut key A and D. So if you press D, next image will automatically come. Then W press, again the rectangle box is ready. You can draw the rectangle box. W, A, D, Control S. These are the things that you are going to use. So by which you can do the annotations part very quickly. So for the time being, I'm just shown how to use this label image tool to do the annotations for object detection. Right? So that's all about it. So once you have these XML files, so you have all the images and XML files in the same folder. So you might be dividing the whole data set into train and test already. If you're not done, we'll be providing another code snippet, which will be doing that part. So in the beginning, you might going for a data set, complete whole images in one folder with all the XML files, or otherwise 2 folders with train and test having images and XML files, corresponding XML files in those folders. So once you have this data set, then we're going to perform the actual process. So coming into the drive, Google Drive part, you might already downloaded all the required files. So the second file we're going to use TensorFlow models. So this is a GitHub repository where you can have TensorFlow models directly available. Whatever research is going on related to this inside the using the TensorFlow for object detection applications, image segmentation applications, or GAN or text-based applications, all these things will be available here. So I'm going to download that Git page. Just I want to show it. So this is going to be the GitHub page. So under community, official, orbit, and research, and this is research folder we are going to use. Okay, so this research, what is inside, all different applications are there. Specifically, we are going to concentrate on object detection. And once you click this object detection, you are going to have many things available, which we are going to see later one by one. So this is what I mean by object detection. You have to identify where the person is, and you have to classify that this object is person. Right, so there is a procedure given how to install this, how to use this, and those you can check it here, TensorFlow 2.x, or if you are using the older TensorFlow 1 version, then you can go it here. So that process we will do now. So I'm going to drive part, and so this is the TensorFlow folder that I asked you to create in your Google Drive. In the PDF. In the PDF, there is given a procedure. If you can see, procedure. So download TensorFlow models and open your Google Drive. Right click on the folder. You extract the TensorFlow while you're extracting in the Google Drive. It will be named as models master extracted something. So then you have to rename it as models and bring that models directly inside the TensorFlow directory. So that is what is the first step. So we are creating in the Google Drive one TensorFlow folder, and inside that TensorFlow folder, we are going to drop the models folder. This models folder is the whole thing that we are seeing in the GitHub repository. Not only this object detection from here. So this is the whole thing that is available now in the models directory. This takes around 20 minutes if you are downloading now and extracting and again you're going to save it in G Drive. So this part, if you're not doing, then you're not able to follow along with me. So this has to be copied already, right? So once you have this, I provided a directory paths, how it has to be created. All these things, we'll be seeing them one by one. So all the links, and after downloading those links, where you have to keep it, in which folder you have to keep it. So this is what we are seeing, TensorFlow, and one models folder we have copied already, right? So this add-ons is optional. You don't need to do this. This part is required when you are working in your own system, not in Colab. So this add-ons part is not required for you. Next one, scripts folder should be there. Workspace folder should be there. In the scripts, additional programs that we are going to use, that things we will be copying in pre-processing stage. That means I said if you are having a data set in only one single folder, you have to divide that into two parts, and the corresponding XML files has to go there. If you are not doing it manually, you can do it automatically by using this scripts that we are providing under the pre-processing. So those scripts we are going to copy here. So one is splitting the data set into train and test and keeping them in a proper place. And the next one is the TensorFlow is not going to accept XML files as it is for the annotations. We are going to convert those XML files into CSV, and of course, now the procedure changed already. We are no need to convert XML to CSV, directly XML to TensorFlow TF records, we can do it. So that script also will be present here. Pre-processing will consist of two files. One is splitting your data sets and converting XML file annotations to TF record format. So those two files will be available in pre-processing, and those two files are third file and sixth file, which are provided here. You can download them and you should be keeping them in pre-processing. Now, once this higher level directory structure, if it is over, then we are going to use under the training demo workspace. So this here we are going to do our projects. So this is the training demo. So you have to follow specific directory structure. So under the training demo, we created again many folders. So the annotations folder will be having the CSV files if it is there, Of course, today we're going to see direct conversion of XML to TF records. But earlier we used to do XML to CSV, CSV to TF records. So whatever those annotations are there, CSV files and TF record files, those things will go into annotations folder once we create them, right? So next one is exported models. Once we create the model, once we train the model, after the training, we will be getting a checkpoints, that is weights files. From those weights files, we'll be creating the model so that can be used for the inference. So that models will be kept in under the exported models. That means saved models. You can think like once you completed your training procedure, you'll be having a model which has to be saved under exported models. And the next one is dataset, image, test and train splits properly. They'll be stored here. And this image dataset I already provided in the link, which consists of a playing cards dataset, which is roughly having 730 images in it. Next, models is the folder where our checkpoints or weights files we're going to save while we are training. Right? So while we are training, we are going to use this models directory where the training configuration will be present inside this directory, and as well as all the training, all the weights that will be saved here while we are doing the training part. Here we are going to download pre-trained models, of course pre-trained model weights. From there we are going to use, that means always we are applying transfer learning. You can think transfer learning and fine tuning. That is what we are going to apply for object detection if we are using TensorFlow. These things, if you are interested, you can prepare your own config file. Then you can start the training from scratch. But that is going to be difficult in the beginning stage. That's why we are going to download the existing models with the weights, and those weights will be used to start our training procedure. From there it will start, and we will go training for some epochs. After that, we'll be having weights file again, trained weights file. So that weights file, we are going to save it under the exported models. These three folders, don't get confused. Pre-trained models are already existing models from the TensorFlow. We'll be downloading them and keeping it. So while training, whatever checkpoints or whatever weights files are there, those weight files will go into the models directly. Once the training is over, we'll be using this model checkpoints from the models, and we'll save the model into the exported models. That is how it goes. So keep track all these folders, because many times it will be getting confused to understand what folder is for what purpose. So if you are able to understand this, then we can start the actual procedure. So this is it, models. Add-ons, I'm not keeping anything because I said I'm not working in my own system, I'm working in cloud. So I'm not going to use the label image. Anyhow, that label image won't work in Colab. There is other procedures that can be done in Colab. You can do the annotations inside the Colab as well, but we are not discussing that here. Models, let us see. So this is the total GitHub repository. We'll come back again. Let me show all the folders, scripts. Pre-processing. I said two files will be there. One is partition the data set, and another one is generate the TF records. TensorFlow workspace. Here, this folder should be consisting of your number of projects, different projects. This is training demo. You can create a project 1, project 2, right? So the folder convert different types of folders that we have created inside the training demo. The same structure has each project. So annotations, exported models, images, models, pre-trained models, and these files will come automatically while we are doing annotations. main problem in using the TensorFlow for object detection or segmentation is these folders, and you have to create and you have to remember what is where. So as I said, test labels CSV is not required for you, but anyhow they are there. We are going to convert XML to directly to TF record files without using CSVs. Okay, test record and train record, these are the files which consists of data set. This is the data set now. You are not providing images or you are not providing XMLs. So this is the data set. This data set will be providing into the model. And label map you have to create. So where it will be defining how many classes are there in our data set. If my classes are in this particular example, we are using playing cards of 9, 10, J, Q, K, and A. So 6 classes are there. So those details I'll be showing you. This label map is already provided to you, I think. So you have already copied this label map into this specific folder. So let us just open and see what is there. Yeah, this is how you have to create your own classes. Your own classes 9, 10, Jack, King, King, Ace. So likewise 6 items are created. So by default 0 will not be used and 0 is considered as background. Once we complete that training demo, back to this exported models, later we'll see. Images is already there for you. You might have already downloaded that and kept in the same place. And I can show you what are the images that we are going to use. This inference folder is also shared. This inference we'll be using for testing purpose at the end. Train folder is there. It's the image file and the corresponding XML files are there. This is how you have to maintain, even for the test case. Once we have this, we will be using TF records conversion. Then annotations folder will get these test record and train record. Models. For the time being, I downloaded 2 models. In the models, I trained the SSD mobile net. I will show you how to do this in the coming session. Pre-trained models, here we have to download the actual architectures. This structure you understand, then only we can go into the actual part. Models, research. We created one document collab file inside the research folder. From there you can have to start. So this file, open. Okay, so connect it. So while doing this connect, how many of you are ready with this position? Are you doing in parallel? Connect. And do remember, while connecting, runtime has to be at least minimum GPU. So runtime we have to check what is allocated by the Google by default. By default, my drive is automatically mounted. Runtime, just checking, change runtime, GPU. So at least minimum GPU is allocated. So we can go ahead. Going into the research folder. These steps we are going to follow as it is from the TensorFlow. I'll show here. So these are the initial steps that you have to perform. And do remember here you have to remember that if you are using the PIP version 21 or later, you are going to face problem if you are following the same structure. So to remember, if it is a less than 20 version, less than 21 version, then only you have to go. So the protos, it will take some time if you are doing parallel. So this line is done. Copying the dot file. Running this step is over. Now here you have to remember that pip has to be upgraded to the newest version, that is pip to 21 or more than that. If you are installing this more than that, then this line use resolver. This part you can remove it. If you are using less than 21, then only you have to use it. If it is more than greater than 21, then you should not use this. So I'm upgrading it. So I know it is 21.3.1. So I remove that. If it is 20, you have to use that. It will take some time. So some errors is common. So this multiprocess and these things are not going to affect our object detection part. This library TensorFlow models is not only limited for object detections. Many other applications are there. Sometimes you will see this kind of errors. No, it doesn't matter. We will continue with this import OS, and this path I am providing so that it can easily find out where it has to look for the remaining functions. So here we are going to test whether you perform properly the installation of object detection API from the TensorFlow 2. So this line will check all the tests for it, whether you have installed the object detection API from the TensorFlow. So it completed 24 tests and everything is okay. So you have installed object detection API properly. Now this line we are not going to use because we have provided the dataset in proper order, like creating, train and test. Both folders are given properly for you. So we are not going to run this line. Otherwise, if you have data that you have to keep in images folder, like here, in images folder, if you don't have train and test folders are separated for inference, all these things, if it are only one folder, you have all the images and XML files, then what you have to do? Then you have to understand this part. So what it's saying, so you have to select the image directory where you have to store that, and you have to create an output directory where it has to be stored. So we will be providing this image directory where you have all the images and XML files, and you provide this output directory. If you are not providing this output directory, defaultly it will save inside the images folder, and it will automatically create a test and train folders for you. You don't need to create. So this program has all the things, and it will do it automatically. It will take the images and XML files from your folder inside the images directory, and it will create train and test folders for you, and it will automatically divide the partition by this value. That means 10% to the test and 90% to the train. So it will automatically divide and keep it for you. So once you have this data set, this time in this particular application, we are already provided you train and test folders with the corresponding XML files. The next thing we have to do is XML to TF record conversion. So you have the file already available with you, generate TF record.py. In the folder, that is scripts under pre-processing. From the main directory, TensorFlow scripts pre-processing, under that you will be finding this generate TF record.py. So this file we are going to use. So for this, what we have to do is path to images folder, train or test. You have to provide. Along with it, label map. So this label map is provided. Let us see the label map now. So this label map you have to create and store it in annotations label map. So this file you have to store it. Then train.record where you have to store. Again, annotations folder we are going to store. So these things we are going to perform. So we are converting. Let me delete this existing TF records and train records. Delete it. So it will take some time to create. Let it create. So now the actual annotations cells will be created. If we have validation, then validation you have to write separately. From scratch. Quickly we'll go through to that point. Successfully created TF requirements. space, training demo, annotations. Right, two record files ready. Next thing is you have to download the model, model files. So So these are the models available. You can download any D1 640 and SSD mobile net V2. It will take some time. Download them. Efficient at D1 and SSD mobile net V2. So the first line, you're going to change from 1000 classes for ImageNet to 6 classes, because our dataset is image size you can modify. And from here on, the model goes on. You don't need to change anything. You're not training configuration. Here the batch size you have to change. You are using Colab. You don't have a proper resource, so the batch sizes might be generally used as 64 and 128 like that. So we're going to reduce that. We don't have a bigger GPU, so 2 batch size. Horizontal flip, random crop. These are the data augmentation techniques that used. You can add more are available. Optimizer you can modify. Learning rates you can modify. These are the defaults for this particular SSD mobile net. Here is the line you are going to change. The fine-tune checkpoint, pre-trained weights that you have downloaded, the pre-trained models, same model, are checkpoints, right? So under the checkpoint, you'll be having CKPT 0 index. That file you are going to copy here. The complete path I have provided. So after that, number of steps you want to train, 1000, 5000, 10,000, whatever you wish. After that, label map. So label map is inside the annotations folder that I created, annotations under label map. Input path, TF record, train TF record format. So that is here. Focus detection metrics. This also you have to remember. Detection, you are performing detection, and that too COCO format. Label map again, annotations inside the annotations folder. Inside folder again a test record file. So these are the lines that you are going to change in this config file. So one is input path for test and train, label map path, number of steps that you are trained, from where the pre-trained weights you have to access, batch size you have to change, smaller value, number of classes you have to change. So these are the few points you have to change. Once you change that, you can start training. The training line goes like this. Model main TF2. Now this model main TF2.py is not there in the beginning for your model. So here these two are not there for you. You have to copy them from somewhere else. So that somewhere else is models, research, object detection, under which you will be finding it. Model main TF2, export, inference graph. These are the things we need. So those things are copied here. So this model main TF2.file we are going to use. For this, what are the parameters that we have to provide? We have to provide models under which one folder where we kept a pipeline config. So under models, SSD underscore mobile net. This is the folder that we have created. So that we have to change. After the pipeline config, pipeline is inside that same folder, right? So this also you have to change. So once you've done that, you are working at now. TF record. Okay. So we have to move into the. So let me go from here. Drive. TensorFlow. Workspace. Training demo. So here the model main files are there. So this copy path you have to go into that directory. So then you can write the runs. I have given 5,000 loops, I think, in the pipeline config, so it will take one good amount of time. So let me cross check that. Okay, so number of steps 5,000. So it will take some time. So you can wait up to that time. From here, it will take at least 5. It's not more than that. So why it stopped? Because I already trained this model for 5,000 epochs already. So let me show that. Training demo models system. So these are the index checkpoints. 6, 7 1. See, now it's training. Because I trained up to already 5,000 epochs, it is stopping there because this is not training at all. Like even up to 5,000 epochs, you have to train. I already trained this 8,000. So that's why it's stopping. Now it will train up to next 1,000 epochs. Classification laws and localization laws. Of course, we are using mobile net. The accuracy will not be good. $6,000 per step. So the epochs are over. Now we have to export the model. We are going to use those checkpoints from here, and we are going to export into the exported models directly. After that, we can start inference. Inference complete file I'm going to copy in one cell. So I'm going to create a So now here, this is for COCO dataset, 90 classes. We want only 6 classes. So I'm going to remove them. So we are going to copy those 6 classes. Is we 9. These are the cards. So label have copied. So we have to provide an image. Image has to be provided and formatted according to the inference. So that file. So model we have saved some place exported models that we will be using. This part we will change later. This is a standard code that we can use. Right. So now going back, exported model is over. Now let's see exported model folder. Exported model. So you can see under this, you'll be finding checkpoints folder, saved model, and pipeline config, similar to what we saw when we download the pre-trained models. These 3 files, you'll be able to see from the pre-trained models. So pre-trained models, they will be having the same directory structure: checkpoint, saved model, pipeline. So these are the 3 files that required for any model to be saved and uploaded and given to other people. So this they can use. Back. This, all the requirements, index, labels. This is a simple function to read an image. Here we are going to change the path. Efficient, that is not the right thing. That's okay. Space, training demo, exported models, SSD mobile net. So this is the saved model. So this copy path, saved model. So that is the path we are going to use. This it takes some time to load the model. Yes, we actually copied images in a different folder. Space training demo images under that inference folder. That inference folder we are going to use now. So this I'm going to paste here. So under the inference, whatever images are there, those images will be used for testing model. So I'm going to change this for the time being, and all the images results has to be stored in the DOM. So it's run. Model is loaded. Now we can run. This result will be very poor by default because using mobile net, and we can improve that by using a efficient net, which we have already downloaded and kept in the pre-trained models readily. So this FDET quickly we'll see how that will improve. So this is how detections are very much poor. At least detections are happening. Now if you want to go with a different model, go with the efficient net, we have to create models. Under the models, create a folder fdet. I have to copy the config file. So for the time being, I am moving it. I don't want to download and upload again and again. So I'm going to move it. Efficient det pipeline config, move. You have to move it. Or I can say make a copy, right? There is make a copy. So this I will move. Back models fdet. Over here. Change the name to pipeline, and we have to edit this file. Config, open. Do remember Coco dataset. We have 90 classes. All those things we need to change. Okay. So here 90, our data is 6. Image size is increased. Efficient data takes the same size. We are going to keep it as it is. We are not getting there are many parameters that need to be tuned according to the application, according to the type of objects that we are going to detect. This I observed many things can be changed, like these thresholds we can play with. Here anchor scales, aspect ratios, you can change it. If you have elongated objects, then you have to change this. This is generalized, like objects will be of squared shape, maybe rectangle shape, like that. If it is elongated object, then you need to change it. So post processing, non-max suppression, this value also you can change, you can play with 0.6 and 0.4. Many things are there like that. Focal loss, this also you can change, adjust these values. These two are again changeable parameters. Train config, we are going to change it to 2. Horizontal flip was the only thing used. Random crop is given. Optimizer again, 3 lakh loops, we are going to change that. At least we will keep 3000. And start warm-up steps as 250. We also will keep it 3000. And this line you're going to change. Not this line. This line is also you have to change. This is a checkpoint line. So the checkpoint line will copy first, and later I will change that. So this is going to change. So this is retain models, efficient at name. Right. So checkpoint security is that's completed. Now this path has to be configured for label map under the annotations folder, right? So the label map is going to be the same for even if we use SSD model or efficient. So under the annotations labels, this I will copy. So this I have to keep it under the annotations label map. Similarly, TF record, train.tf record, that is also present in under the annotations only. So train.tf record, that is the input data. Verify this matrix right. Path to be configured, label.map. In here, test.tf records. And one thing forgot to is true, you have to write as false, because we are not going to use TPUs. This is specific to GPU. This line you have to remember. If you are using TPU, then you can write it true. If it supports floating point 16 kind of variables, then we can use. Some of the graphics cards it supports. and the classification has to be changed to detection. These are the two things that you need to know again. Right, so this file is complete. So complete. So training main. Now this is going to change fdet, and pipeline is present in fdet folder. Run this. I given 3000, so it will take some time. After that, we will change all those values. So mobile net fdet models fdet directory. Now here you are going to face problem exporter main, and it will search for this fdet folder. So this folder will not be there. So we have to create that. Exporter models fdet. Create it. It's giving some error. I think pipeline I did something missing. I think it's train.records, I think. Demo foundations. That's right, train.record. So that is what is the mistake. Yep, record. Let's start record. Save it. And so it's over. So remaining, you don't need to change anything. Okay, saved model. I'm going to save here fdet. Some error. What is not found? Label map.txt. It should be pbtxt. pb. Save it. So refresh it for the drive to reflect in the Colab. We can run this. If flow goes like initially, you're going to open label image, create your data set in a single folder, all the 100 images, 100 XML files. Once you complete in label image, then you're going to use TF record conversion. Data set split, partition data set file will be there under scripts. So use it to create train and test folder with 90 and 10% splitting of all 100 images. Next, TF record. In the script, under the scripts preprocessing, TF record file will be there. Use it to convert XML to TF record format. Once the TF record format is there, you have to give this label map tbtxt. One file you have to create under the annotations. Give all the labels that you want, that you have in your data set. That is the start step. Download the pre-trained weights of any model. Fourth step. Keep it in pre-trained models. Copy the pipeline config to your models. Open the config. You have to edit many things. files like classes, batch size, CKPT 0, wait 0 file, and detection, and do not use if it is not TPU, one name, train record, TF record paths, label map paths in the config file. So once the config file is ready, you can train it. So once training is over, all the CKPT files, wait files will be stored in the model directory. So those files, use it to export the model. To export the model, new model will be created under the exported models. So that model we are going to use for inference. And this directory structure, if you can maintain properly, thing is going to be it is going to be easy for you to track what is happening where. You can create multiple projects of object detections here on. So go under workspace, create a new folder, create all the folders the same what you find in training demo. All these folders, copy them into the new folder and remove whatever is required and start from there. Remaining everything will be ready. It is very big loss. is to 500. Done. I'm going to stop this. See, one file saved till now. Okay, one more point we have to say. This is not going to save model weights for every 100 steps. We have to wait for 1000, 2000 steps in between. From maybe in between 600, 700, it will store. Maybe in between some 900 and 1000, it will store until we get something here, new value. This is showing 0001. If it comes shows new value, then only we can start stop that and we can export the model with that weights. I closed it. I will use the same CKPT file, one file that is there. Net export.
because of this.
Because we didn't trained in the end update, so the next value is not changed at all. So this is the initial point, so that's why it is not taking and it is not giving anything in the exported models once we export. So once you have models here, you have more values, CKPT 3, 4, like what we have seen in the SSD mobile net. Then you can have, or you can export the model and then you can train the inference. Then you can see the result. Thanks for it.